So good morning, gentlemen. This section of the class will be focusing on how to use one of the simplest software to do stormwater management model. As I said yesterday, computer softwares are meant to model and simulate. So for you to calculate the pipe sizing and everything, you have to do it. Just like we did yesterday, you have to use the Excel sheet and calculate the pipe sizing. It is those parameters that you got that you now put into the software. What the software will now do for you is to calculate and tell you if your sizing is adequate, if your pipes are adequate. It will now give you the flows at every node, at every section. It will also show you the areas that are flooding, the area that are surcharging, and the area that are normal. Now, those three words, I use them very clearly. Normal flow, surcharge, and flooding. Flooding means it has gone beyond your size. It has started flooding. Surcharge means it's flowing full. The normal is like flowing normally, maybe at 90%, 80%, or 70% pipe full capacity, which is what the standard says. The standard says that your drain is supposed to conduct between 70 to 90% of your flow. So just like we do in dams, after building a dam, you must give a freeboard. Okay, you must give some people say safety measures. So the same thing applies in drains. You don't mean your drain to be flowing 100% full. No, that is not design. Design means the maximum, the upper limit is 90%, while the lower limit is 70. If you now design and it is 50% full, that somebody can accuse you of over designing. So let's go to the SWMM software. That's our focus for today. So this is the SWMM software. You download from EPA. After downloading from EPA, you open the software. So this is the interface of the software. Now, before you open the software, I assumed that you have done your calculation sheets for the sewer. Yes, something like this, maybe up to 100 pipe sizes or whatever, depending on the capacity of your design. And then you have done for the storm this way. So for the purpose of this design, we're going to use storm to do the software, but it's the same thing that you'll be doing in sewer. Why we are using storm is that we need to create a rain gauge. In the case of sewer, you don't need a rain gauge. All you need is to make assumption of water demand, the water demand per capita per person per day. So, but for the storm, you need to create an artificial rain so that there will be precipitation in the software. Then the software will now compute based on the area and now tell you, okay, this drain size is adequate. And let me also say this. The major output of hydraulic analysis is pipe sizing. The output, whenever you are doing any hydraulics, whether sewer or stormwater, the end product is what are the size of the pipe we need. But then, before you get the size of the pipe, you need to say, what is the flow that this pipe is meant to convey? And before you do the flow, you will now ask yourself, how do I generate the flow? For the stormwater, you need two parameters to generate the flow. And that is the area that the flow is coming from and what is causing the flow, which is your storm or rainfall. For the sewer, what is generating the flow is the water demand that they are consuming. So that one is pretty easy. Only that you have to multiply by the safety factor and add infiltration flow, because it is not airtight. So we have a drawing like this given to us in PDF. Okay, if it's an AutoCAD, you can also use it. I'll do the one for AutoCAD too. So if this is in PDF, my first job is to import it, the layout on SWMM. Why do I need to import the layout? When I import the layout, it will help to guide me to know where is the boundary, the catchment boundaries. Help me to know where the drains are located. Help me to know where the houses are located. It will give me an aerial overview of my catchments. So we're going to use this as our case study. So all we need to do now is to import this image and then use it as a guide to develop our own catchment within the SWMM software. So if I'm giving this image we did yesterday, I'll simply go here. I'll take a snapshot. I'll come here I will snap what I want to export. It will be copied to the clipboard. I will now go and type paint. I open paint. I will say Ctrl V or just paste, and then I'll click crop. So to crop to date. Then I will save it or export it, whatever word you use, as BMP. BMP and JPEG are the same, but BMP is older than JPEG. So I'll save it as Abuja drawing. Abuja drawing. Okay. Abuja drawing. I'll save it in a particular location. Let me say desktop. I'll click save. I'll now go back. I'll close it, of course. Sometimes when you do something, close one file before opening another one. It's very important so that they will not conflict. So I'll go back to the SWMM software. This is my layout. I've explained the layout yesterday, how this layout is. These are your toolbars. These are your standard menu toolbars. These are your the menu bars. These are your browser, project browser toolbars. These are your drawing area, and so on and so forth. So I'll go to view, backdrop, load. I'll look for it through this flyout. I'll browse for it. It's on my desktop. So I'll go to my desktop and I will see Abuja drawing. Look at it. I'll click on it. I'll click open. If there is a coordinate, some georeferencing that is involved, I'll click this, but there's no georeferencing, just forget about it. I'll click OK. It has been imported. You grab it. If the drawing is in AutoCAD, I will do this almost the same thing. Let me finish with this. So now the next thing I will do is I will try to draw this out in SWMM. When I draw it out in SWMM, I can remove the background and then start my work. Okay, if you want to do any model, the first thing you do is to draw the model, draw the physical model. If you want to do work on any structure, all you need to do is to draw the structure. If you want to do a structural drawing, you have to import your architectural drawing, log out some layers, and then you start to digitize. Now you now try to draw your beams, your columns, your slabs, and everything. So it is the same engineering methodology of modeling, which some of us call detailing. So we are also detailing. In GIS world, we call it digitalization. Okay, so any word you use is simply the same thing. So now, this A is a catchment, B is a catchment, E is a catchment, F is a catchment. So this is subcatchment here. That's the symbol, the icon for subcatchment. So I'll click on subcatchment. The icon will turn to a pencil. So I'll draw out this catchment out. I'll click here. I'll click at the edge. I'll click here. I'll trace the boundary. When I get to the end, I will just right click. It will close up. So this becomes catchment A. But before I do that, there's something I forgot to tell you. So I'll click on it again. I'll click delete. I'll delete it. When you open any software for detailing, the first thing you always do is to set your preferences. Go to options, go to your view, set the preferences, how you want your display to be. So in this case now, I'll go to view, I'll go to tools, I'll go to map display options. There's always something called options in all the softwares. Before you start the software, go to options and do some settings. It's always the case. So in this case, I can go to view, I'll go to dimensions. I'll set my dimensions. I'll set it in meters. Now, if I click this now, this drawing might disappear because I didn't set it before starting, but let me go ahead. Okay, it didn't disappear. So I've set the dimensions in meter. Next, I'll go to tools, map display options. I'll click on it. I will choose how I want the map to display. The node size, I will increase it to say 5 so that to be big, bold enough. The links, which are the pipes. I'll increase the size to 2, just for it to be bold graphically. So this is like a graphic settings, okay? Then I will ask it to display the first 4 for me. Display the rain gauge to display them, to display their names when they show. Symbol, nothing to change here. Flow arrow, I can change it to fill. Is on none. I'll change it to fill. The size, I'll increase it to 10. The background, do I want a white background, black background? Depending on your taste. But I'll leave it as white background. Some people prefer to work on black background. So I'll say okay. Good. Then I'll go to projects, defaults. Let me set the default settings. Defaults. If you go to project, you go to default so that you set defaults. So what are the defaults? So these are the defaults of the labeling style. The rain gauges will be rain gauges. You can click here and change it to G. So if you see G, it means rain gauge. Then for the subcatchments, I can change it to say S only. So anywhere you see S, it means subcatchment. Then under ID increments, I will change it to 1. Why 1? I'm telling the software, if the first catchment is S1, the second one will be S2, the third one will be S3. That's the meaning of 1. Okay? So I'll go to subcatchment, the properties of subcatchment. What is the area of the subcatchment? Is the default is 30. I can change it to 35 or anything. The width, I'll change the width to say, if I'm drawing in meter, an SI unit, I'll change it to say, let's say 150. Sorry, let's say 5. No, not 5. The area should be, okay, let's say whatever, 5, depending on what the area is. The slope, I'll change it. The area of impervious, I'll change it to say 0.7, 70% impervious, which means the coefficient of runoff will be around 0.7. Okay, I can go here and click infiltration model and change it. So I'll not go too deep into all this, because some of them are not necessary. Then I'll go to the node and links. The invert level, I'll leave it at 0. Then the other values, I'll leave it at default. The conduit geometry, what kind of conduit do I want to use? I can change it to say, I want to use a rectangular drain. For the purpose of this training, let's use circular drain. Circular drain asks you what is the height in meters. So let me say 1 meter or 1.2. Let me say it at 1.2. Number of barriers 1. Okay, I'll click OK. That means this is circular and the diameter is 1.2 and it will only be 1. Number of barriers means you can have 2 lines, 2 barrels. I'll say OK. Conduit roughness, I'll put 0.1 or 1, whatever. What is the flow unit? Liter per seconds. You can choose any unit. The link offsets, leave it at depth. So you can then force equation. Is it Hesing-Williams or Dasivashbach? Let's use Dasivashbach. So these are like default settings. But if you want to change any of these default settings, you can still change it before you run your model. But this is like setting the default settings, so that the computer will know that if I didn't put the area of any catchment, it will assume 5. If I didn't put the area of any width, it will assume 150. And so on and so forth. So these are default settings. So you can just use every conduit will say C. But let me change it to pipe. Pipe underscore. So it will be pipe 1, pipe 2, pipe 3, pipe 4, and so on and so forth. Are we together? Okay. So here I'll click OK. Now I'll now go and draw my catchments. So I'll come here. I'll draw these catchments. Sorry, escape. Let me remove this from good. So I'll come here, I'll click here, click on these catchments. I'll trace the boundaries. And when I'm about going, I'll right click to close it. You can see that name it S1. Where is this S1 coming from? It's coming from the settings I've made. So let's draw the second one. I'll draw here. I'll draw here. I'll trace the boundaries. S2. I'll close it. I'm tracing all the catchments, okay? I'm tracing the S4 because these are the catchments that will contribute to runoff or contribute to sewage flow, sewer flow. The difference is that for sewer, I'll be dealing with number of houses there or number of persons. Whereas for the storm, I'm dealing with the catchment area and the runoff coefficient. Good. I have drawn the catchments. The next, I'm going to draw the nodes and the pipes. On the first day of the training, I told us that there are 4 parameters you need to design every hydraulic system. You need 4 parameters. 2 parameters are the nodes, 2 parameters are the pipe. You need 2 properties of the pipe. Number 1 is you need to know the length of the pipe and the diameter of the pipe. For the node, you need to know the elevation and the flow at that node. Please, I want us to take note of it. 4 parameters you need to design any hydraulic systems, because hydraulic systems are made up of nodes or manholes and the pipes. For the pipes, the length of the pipe must be known. You can write it down. The diameter of the pipe must be known. For the nodes, the elevation of the node must be known, and the flow or the discharge or the water demand at that node, at that point in node. Because if I want to put a meter to measure flow, you don't put meters along the pipes. You put the meters at the nodes or at the manholes, or the service manholes or maintenance manhole, whatever you call them. So these nodes are where you can put your meter to read the flow, the discharge, depending on whether it is potable water or wastewater. So the next thing I'm going to do now, I'm going to place the nodes. So this is nodes or junction, sorry, junctions, yeah. So I'll pick junction. Sometimes you have to click on this black one, black select to so to deselect. So your mouse, your cursor will be free. I'm now going to pick add junctions. When I click add junction, if you look here, you will see that junction have shown up. I'll come here, I'll click there, I'll click here. I'm trying to trace the existing ones. You can see it's writing J4, J3, J5, J6, J7, J8, and J9. I'll go and drop it by clicking this black one. Okay. The next thing is to draw the pipes. Now, if I click on the pipe, it turns to a pencil. If I click on this node, it will turn. If I got it right, I must click at the center of the node. If not, it will not draw. If I now go and click here, if it didn't go off like this and name pipe 1, I'm wrong. So I'll come here, I'll click here again. I'll click on this one. It will name it pipe 2, and then it will zoom off. It means it has drawn a segment. If you come here, you'll be seeing pipe 1, pipe 2. Look at it. Because I'm on conduit, the browser is showing me the pipes I have drawn. So if I work on my working area, on the browser area, it will tell me what I'm doing. So here, I'll click on this 4.1, J4, click on J3, it will go off. Now, I'm not seeing those things clearly, so let me drop it. I'll go back to Tools, Map Display option. I'll increase the node size to say 8, the link to say 3, so one can see it very well. So I'll go back again, I'll pick my conduit, which is pipe. I'll click here, turn to a pencil. When I click here, it will go off and you name it number 4. If you come here, you see number 4. Then I'll click here, number 5. I'll click here, number 6, as shown here. I'll click here, number 7. I'll click here, I've drawn it. I'll go and click this black one. So at this point, I'm going to give us a few minutes to play our hands on it. I'll pause the recording now. So now, let's work on the catchment first. If you double-click the catchment now, it will tell you the properties of the catchment. But 2 things are missing. 2 things are missing. And those things that are missing is the rain gauge and the outlet. Where is the water falling on this catchment going to, from where is it going to enter this pipe? Of course, it will enter through a manhole. And that manhole is manhole J1. So under outlet, come here and type J1. If you type J1, you see what will happen. And press enter. You see a dotted line will automatically go from the catchment to the manhole. If I click on this catchment 2 now, the outlet is empty. So I'll put J4, depending on what is here for yourself here. I'll press enter. It will automatically link. So what this thing means is that all the water that are coming on this catchment will flow into this one. That's what it means. All the water that are coming in this catchment will go into this catchment J4, whether it's sewer or storm, but now we're treating storm. So you know, gentlemen, the water that is coming from your house, when it comes out of your house, it will enter the first manhole in front of your house. The water from your streets, when the water leaves your streets, it will enter the manhole on the road, on the major expressway. I want us to put on our imagination. So every catchment, water that is coming from Adeosun Street, Ozumbambadiwe, for instance, there's a particular manhole in front of Ozumbambadiwe that the flow will enter. So from that hole, it will not enter the pipe. So it is important that you identify the closest manhole close to the catchment. That will be the receiving manhole. So for this one, I would click and drag out of it so I can see the catchment very well. So I'll click on catchment 3. I'll tell him that the outlet should be J5. I click enter. It will draw and discharge into J5. I'll click on J4 on S4. There's no outlet. I'll ask him the outlet should be J2. I'll click enter. Okay. If you look at it now, you see that there's a line has been drawn showing that the discharge is going to enter into there. For this one, I will say J3. Enter. I'll drag this one up so I can see it clearly. I'll click on S. Yeah, okay, let me do S5. S5, J3. Okay, that means S6 will be J6. S6, I'll give him J6. Enter. Good. So that means S7, it should go to J8. Then, okay, I hope we're in order. Yes, we're in order. Okay. Then, J7, No, okay, S8 will empty into J7. Then finally, who empties into J9? Or rather, this one should be J9. Yeah. Yes. So it's okay. Then I will now go and click add fall. This is my add fall. I'll put my add fall. So this add fall represents, let's say, something like say river or wastewater plants. I'll click its own conduit from here to here. And that will be pipeline. I'll click on this. I'll click on it. So I just want you to understand that this outfall simply means it could be a river, it could be a stream. So this is now, I've done it this way. Okay. The next thing I'll do is to create a rain gauge. I'll create a rain gauge. So I'll come here, I'll pick rain gauge. Add a rain gauge. I'll drop it here. Okay. I'll click on this black arrow. If you double click this rain gauge, you'll see that it has not been designed. Series name, there's no series name is empty. File name is empty. So you need to fill in those later. But the thing I'm going to do is to I'll go back to my catchment. I'll ask him to reuse this gauge. I'll come here, I'll open this. Because I've created this rain gauge, this flyout is now giving me G1. So that I know I've completed the catchment design. Here, I'll open here. I'll say use G1 as the rain gauge. I'll go here. Oh, this is not catchment. This is pipe. This is still pipe. So I need to click here, move this thing up so I can see my catchment very well. Click on catchments. If you click on the catchment, the property will open. You know whether it's a subcatchment or a pipe or a node. I'll click on this flyout and click on J1. So can you do that also? Click on all the catchments, but that will be after you have created G1. If you didn't create G1, there's rainfall. Nothing will show up here. It's because I've created it. That's why something is showing up here. The same happened here.
Yes, how did you create G1?
Just click on add rain gauge, this icon. Click on this icon, you drop it. So what this thing means is that you have created the rain system. You remember we're talking about precipitation storm. So this is what will bring the storm that will now fall on these catchments and subcatchments. And then we'll now know the effects or the impact on our already designed pipe network and manhole systems. But what we are doing is not design, we are doing modeling. Yes. So I'll click on this one, it has been done. I'll click on this one, it has been done. I'll click on this one. All of them, just make sure all of them captures the rain gauge. In other words, you are telling the catchment that, look, the rain that's going to fall on you will carry the properties of this G1. So later, me and you now, we're going to design this G1. We're going to design it. We're going to design it. So can you do that? So everybody, in the next 2 minutes again. Fulfilled all the requirements. So these are the requirements of my catchment now. In hectares. Okay, look at it now. So catchment in hectares. So I know none of them, the effective area is no more than 5 hectares. Oh, but I'm wrong. This one is about 15. Don't worry, we will edit them later. We'll edit them later. We'll edit them, don't worry. We'll edit them. So I'll give you 5 minutes again. I'm pausing the recording now. Come to speed. So if I click on pipe 3, I'll be imputing their length. So from the chart, from my Excel, pipe C is 730. So let me just say 800. So I'll put it 0.8. The length is 500.
Sorry.
Yeah. 500, yeah. So please, when you input any value, press enter so it will accept it. This one is 500, the length. And it should be the same thing with 0.8 from experience. If you go here, look at it, pipe E. E is, look at it, 770. So D should be higher. D should be 1.2. The length should be like 250. The pipe roughness remains the same. It's constant or true. D. I'm wrong. Oh. D is 2 meters. 2.0. So what would be pipe 6 will be around 2.2. Pipe G, pipe 7 will be what others are, which is around 0.9 or 0.8. The length should be 500. And finally, pipe 8 should be 250. Is it 125? Yeah. And 2 points. I don't know what it is, but let me confirm what it is. The outlet must be the same with the last one. The outlet must be the same in terms of the size because it's just an extension. G. F is 3 meters. That is quite huge. I don't know how I got that. Okay, I'm back. Sorry, my network got me disconnected. So let's continue. Sorry, the network. So now the next thing we do is We have done the catchments, we have done the pipes, then we have done the nodes halfway because some of the nodes have been collected. So now if you click on the node, now, it will be giving you invert level is 0. Invert level cannot be 0. It's not a flat land. So invert level must have a value. And what we'll do now is that let us have a reference. Let us say now if it's in real life, in real design, the surveyor will give you the invert level at all the nodes. That's the standard. Remember, the job of the surveyor is to give you the invert level, the spot height, and that is what you need to compute the elevation. Why you need elevation is that you need elevation so that you will know the direction of flow. Now we have slopes. Now this is very sensitive, and let us get it right. The pipes have slope. Look at them, the pipes have slope, or the catchment have slope. So it means it's not a flat land. And the flow is by gravity. So definitely there must be a gradation from 100 to 91 to 98. Then at the end, you end up at say 95. Okay, so take notes. So here now we're going to use arbitrary slope, but guided by the length. Now let me ask you something, gentlemen. The length of this pipe is 500 meters. If this place is, say, let's use 100 as benchmark. Let's use 100 as benchmark. If this place is 100, for instance, and you are given that the slope is 0.5%, what would this place be? This place would be 0.5%, which is 0.005, multiplied by 100. That will give you the value of this place. It will be complicated for some of us, but we're all engineers. So let me use calculator. The slope of the pipe is 500. So it means that the change in level will be 0.005 multiply by 500. That will give you 2.5. What it means is that if the beginning is 100, the end of the pipe will be 97.5. So I'll come here now. I'll put the invert level here to be 100. Stay with me. Enter. When I come to J2, J2 will now be 97.5. So to just make life easy for us, I'll put here again as say, let's say here and here at the same level. So let's say here will be 100. Therefore, here will now be, let's say, because from here to here is not a flat land. So let's say here will be 97. Are you with me? Here will now be what? Let's say here will be 96. Just to give it a slope, a sloping down. Here will be 95. Stay with me. Here will be 94. And then here will be 93, which is the lowest point, which is the river point, or which is the wastewater treatment plant. So here, let's say here will be around, let's say 98. Because here is 95. So the difference between here and here is 3 meters. And these are about 500 meters, which will give you 0.5% slope. Any confusion? Invert level here, let's say 98, 99. So that when it comes here, here will be 96, which is 3 meter difference for a 500 distance. Makes sense. So all the nodes now have elevation. So this slope, you can see all the parameters are full now. But the only thing that is not here is the flow. We don't have the flow. Are you with me? We don't have the flow. So how do you get the flow? I can put the flow now, the discharge. I open here and put the discharge. And even I know if I'm doing the sewer, here I'll put the factor. I'll design the dry weather flow here for the sewer line. But now we're talking about storm. So because we're talking about storm, the flow into this node will now come from this catchment. And I've told him already that the flow should go to J1. So when the flow enters J1, it will go to J2, to go to J3. The one from this catchment will enter J6. J6 will start flowing. This one will enter J4. J4 will start flowing. When it gets to catchment 5 will put in own flow. So before you know it, all the catchments have started putting flow into the different nodes. So water is not flowing because we have not designed our rain gauge. So once I design this rain gauge, the rain gauge will now be the one that will catalyze this flow. So next, we are going to do our last design, and that is to design the rain gauge system. Now, what have we done so far in the last 1 hour? We have designed the pipe, we have designed the nodes, we have designed the nodes, we have designed the pipe, we have designed the catchments. So the last thing we have to design now is our rain gauge. Are we together? So can I give us another 5 minutes for us to design the elevation of the, so what I did here is 100. So since the slope is 0.5%, here will automatically be 97.5, because 0.05 of 500 meter length means after 500 meter length, I have gone down by 2.5 meters. That's what it means. After half a kilometer, the slope has gone down to about 2.5 meters. So if the spot height here is 100, at a 2.5, at a 0.5 elevation, at a 0.5 slope, which is 0.005, I have come to 97.5. So the first thing you do is to design the mains. So this one is 97.5. This place is 97. This place is 96. So I just remove one, all of them. So if with knowledge of this, it means this one has to be at higher elevation for it to be able to flow. So, but all these things is what the surveyor will give us. But because the surveyor we didn't get it from the surveyor, I was able to get it from the slope here, giving us. These are the slopes. 1 in 500 means I'm losing 1 meter in 500. 1 in 400 means I'm losing 1 meter in 400. Gentlemen, get it now. 1 in 300 means for every 300 meters, I lose 1 meter. 1 in 600 means for every 600 meters, I lose 1 meter. Are you with me? This one means 1 in 200 means for every 100 meters, I'm losing, for every 200 meters, I lose 1 meter. So that means for every 500 meter, what will you lose? You lose 2.5, because if this is 200 for 1, then it means 400 for 2. It means 400 for 2, which automatically means for 500, it will mean 2.5. So I'll give us another 5 minutes to come to speed with this. So design your manhole, your point, your nodes by putting the elevation. So put the elevation for all of them. And for those who have not done for pipe, put in the diameter of the pipe and the length of the pipe. Please, 5 minutes. Thank you. We're making progress. So the next thing now we're going to do is to design our rain gauge system, because we are talking about stormwater. So how do you design your rain gauge? You come here, you double click on the rain gauge. If you click on the rain gauge, you see that you can change the format. We all know that we'll be dealing with intensity. What is the time interval? This is 1 hour, but you can open it and change it to say 10 minutes or 5 minutes. So change it to 5 minutes. I'll tell you why. So we will give updates that the rain is changing every 5 minutes, and that's how our rain here does. Not hourly. So it's 5 minutes. Snow factor, we are not in a snow country, just leave it at 1. That means If it is snow factor, you can use 1 point something, 1 point, just to add the additional load coming from snow. But 1.0 means when you multiply something by 1, you're leaving it default the way it is. Our data source, do we have a file that we can just upload, or time series? We'll choose time series. We're going to build a time series. Series name, there's no name. We've not created any series name. So we are now going to click a name. If you click a name, if you come here, it will show that name. You now update that name. So here we said data source can either be from file or from time series. If it is from file, then you need to come and click the file name, create a file, pick it where you save it, and so on and so forth. And that file can come from River Basin or from a professor in one of the universities that have modeled the rainfall system of that area. But for today, we'll be using time series. So our job is to go and create a time series. Engineer John, you have a question? Did it come?
Yes. Sorry to draw you back. The time interval.
Yes.
You said 5 minutes, but that's 0.05. 0.05. That's
okay.
dividing by 24 hours.
Okay. Now, when you see in this software, when you see something like this, the first one is hour. Oh, that's the second one is minutes. Hours and minutes. So when I put 5 here, if I put 50, it will be 50 minutes. I don't know if that's what you're asking. Yeah.
Okay.
You'll see that shortly. Don't worry. So what I'm going to do now is I'm going to click on my rain gauge. Double click on it. Yeah. You'll see that I want to create a time series. So I'll close it back. Come down here. Come to my browser. You will see where they say time series. Click on time series. There's no time series. Click on time series. There's no time series. So you click on this plus to add the time series. So click plus. If I click on plus, a dialog box will open. So on this dialog box, I'll call it Lagos. Lagos rain, Lagos time series, Lagos TS, Lagos time series. Under description, you can write anything. Lagos mainland or anything, just write anything. Lagos mainland, because mainland might be different from island series. So you can just indicate what it is, but no need if you want to just leave it blank. Okay. Dates, you can leave dates, time, and this thing. So here, under time, I will say 0-00, which is when the rain starts. The value is 0. I will put after 5 minutes, which is 0,05. The rain is 10 millimeters. Just stay with me. After 10 minutes, the rain is 50 millimeters. After 15 minutes, which should be my critical time because of my 15 minutes rain or 20 minute rain, the rain is now 100 millimeters. So this one, after 5 minutes, the rain cannot be this. Let's say the rain is 50 meters, 50 mm, here 75. Then after this, 125 or 150. Then after 20 minutes, the rain is now 150, which is the maximum. After 25 minutes, the rain start coming down. The rain is back at 100. After 30 minutes. So that will be 30 minutes rain. The rain is back at. Okay, let me make it at 5 minutes rain. or even 40 minutes rain. The rain start coming down. Then after 40 minutes, the rain stops. So this is what a time series, a typical time series look like. And for those of you who are science inclined, if you now want to confirm whether I have done a good job, you click on view. This is what the rain is like. I don't know how many of us have heard about block rain. The normal rain system comes as a block. And if you want it to come as a block, what I will have done is to put 1, 2, 5 here. That means the rain has plateaued. Has plateaued here. I'll click it. So more like this. You know, rain, when rain gets to a level, it plateaus. It plateaus. And then start coming down, start receding. This is the typical how a rain functions. The rain starts, it goes. After 15, 20 minutes, it peaks. It gives me 120 mm rain, which is the maximum I'm expecting, 125 mm. Then after 40 minutes, it goes back to 0. Any question on this? This is what a typical rain is. I'll close it. Now watch this thing. This is Lagos TS. Series name, Lagos TS. I'll click OK. I will now go to the rain gauge now. Under series name, I'll open it. Lagos TS will appear because I've created a series for it. I'll now click OK. It will absorb it. Case closed. I've designed the rainfall. And the rainfall has already been incorporated on my catchment by G1. So this catchment now, when I run my simulation, it will be seeing the rain coming from that series, based on that series, that will give a maximum of 125 mm rainfall coming into my rain gauge system. Don't mind that these ones are still harsh because we're not using the file system, we're using the time series system. So can you quickly create your rain gauge, people, before I run my own? And then for that one, I'll give you only 1 minute. Create the rain gauge in 1 minute. So now what we have done, we have designed the component of this rain system. We have designed the rain gauge by using intensity and then giving it this time interval of 0.05 and then creating a time series name called Lagos TS. Okay, we have done the catchment, we have imputed the catchment, the outlets of the catchment, the rain gauge to be used for the catchment, the area of the catchment, the impervious area of the catchment, and the slope of the catchment. For the nodes, we have imputed the invert level of each of the nodes, and the flow is coming from the catchment. Okay, the flow is coming from the catchment, and it has been automatically linked to it. So we are good to go. So the next thing I will do is I'll run my model. Wow, it says unsuccessful. The good thing is that when the model is unsuccessful, if you click on the software will tell you where the mistake is. Okay, he said you cannot open rainfall file. So there's a problem with my rainfall file, but I didn't use file. So I'll go to my rain gauge system. Oh, I know the mistake. Okay, no. Series name this. File this. Yours is successful, yeah?
Yes, sir.
Sir, change your data source to
Thank you, sir.
Time series.
God bless you.
Yeah.
So this is another good thing about this software. So you make a mistake, it will tell you unsuccessful, but it will quickly point you to where your mistake is. Even for the other training, water recirculation system, the one we use EPANET. If you make any mistake, after you've done your hydrological model, you've done your report, to tell you where the mistake is. So let me go. So successful. The runoff is good. The flow routing is not bad. Good. I'll say okay. So if I want to view my result visually, I'll go to map, look at map view, map. Then I'll choose maybe catchments under node. I will choose where is flooding. Then link, I'll choose velocity. and I can run the model. So I'll come here, I'll click play. So it will tell me throughout the duration of my running. It will tell me where the mistakes are. Now, you might not understand much here, but this is just to show off. For me, this is to show off. This is basically to show off. Okay. Why is it to show off? Because I am running this velocity, I'm running this, so the system will now tell me where there are errors. Like here now, the areas are the same. Flooding now, none of them turn to red because I didn't set the limits where it will flood. Okay, so this is the flow in liter per seconds. If I double click this now, sorry, it has gone out. If it goes out, I'll go to tools. I'll go to views, legend. I'll bring back the node. I'll click node to come back. If I right click on this, okay, I can play around with it. So I can say when the velocity is above 5, turn red, change it to 2, change it to 0.5, something like that. Change it to 0.1. I'll click OK. I'll run the model again. I'll click play. You can see at some point, some change to red, some change to green. So what will give you those answers is what you have defined in your legend. But then what we'll now do is we'll go and get our report. So you go and click on reports. Reports. You click on reports. There are 5 reports you can generate from these charts. You can generate 5 reports here. The first one is status reports. So if I click status reports, it will give me a summary. It will give me a summary of the status of my design. Now, some of these things are something some of us might not be familiar with, but it makes sense for somebody who is a water person. So here, it will give you the values I use. The flow unit is this, rainfall, yes, snow melt, there's no snow melt, groundwater flow, there's no groundwater flow. All these things to tell you everything. Then, next, it will now tell you total precipitation. Evaporation loss, you didn't do for that. Infiltration loss, it will give you surface runoff. This is where we're interested in. This is surface runoff. Final storage, continuity. Dry weather flow is 0 because we didn't design for dry weather flow. Wet weather flow, it has completed it. External flow, it has done it. So that is the status report, not too important. Summary reports. So this is summary report. This is one you print. This one is just like our Excel, okay? But if you want to copy it out, this is for subcatchment runoff. So this is the total runoff per catchment. The peak, the runoff coefficient. Have you seen that it has recomputed the runoff coefficient for us? It used because we only gave it the area of impervious. It not calculated the runoff coefficients it used for each of them. Give us the peak runoff, so give us the total runoff, and so on and so forth. So you can copy this now, for instance. If you click here, you go to edit. You say copy to. Copy to clipboard. Hold on. Just stay with me. Can't find my.
Excuse me, sir. My phone went off. all of a sudden, so I missed.
So it's here.
So
Where did you miss? Where did you stop?
I was at we were at the status report.
Nothing much. Status report is just status report. The next thing is a summary report. So we're in summary report now, which is the next report.
Okay, sir.
Yes. So now, summary report. Just hold on. Let me see if this will work. Yeah, it worked. It has worked. So for summary reports, this is summary reports. So how do I get summary reports? I go to reports, summary. So to summarize for the subcatchments, it can summarize everything about subcatchments. If I open here, I can go to the nodes. You tell me everything about the node depth. Everything about the node depth. I go to flooding. You see some nodes are flooding. At this hour, this node flooded. This charge is so high. Only for a few minutes. It flooded after 40 minutes. Then surcharge. About 5 pipes are surcharging. Tell me what is happening in everything. Link flow. This is the flow in the link. So you will be clicking on all of them. Inflow, depending on the one you want to make sense out of. But for now, just the we've not really gotten to this level, so some of us will not understand it. But a hydraulic engineer look at all these things, he will make sense out of it. So you can click each of them and paste them in your Excel. Then let's go to the next, so I can close it. We'll go to graphic reports. Graphic reports can come as time series, profile plot, and scatter diagram. So let me click profile plot, for instance. Profile plot, I'll click on here. I'll click on any particular node. Add. Then end node. Find paths. So this is what the profile plot looks like. I'll go to map view for me to simulate it. So at the beginning of the rain, this is what this is what after 5 minutes. Oh, this is 15 minutes. Time of the day. Let me start from 5 minutes. There's something wrong here. This is being done in 15 minutes. Okay, let me do that. I think I'll change it later on. So here, rain has started. Has gone up. Has started going down. So I think I need to set something to make it for 5 minutes. Let me do that setting. So here I'll say projects default, project default. Okay. Subcatchments. Simulation. I'm trying to find. Just stay with me, I'm coming. Okay, good. Under options, time step. I go to time step. Here it says 15 minutes, reporting time 15 minutes. I'll change it to 5 minutes. Sorry. So 15 minutes is the minimum. It's not. So for 5 minutes, I'll change it to 5 minutes. So it's going to give me results every 5 minutes. So analysis is for 1 hour. I'll change here to 1 hour. Just 1 hour, because it's 40 minutes rain. So here you do all the settings, simulation option, look at it. Simulation option. You can do your settings here. Check the curve number, the rough tone, the rainfall model. Is it kinematic wave? Is it dynamic wave? All these things are something, if you read the manual, you understand all what they talked about. There's no point teaching you something that will not be of value to you, but if you want to know more about them, you do them up. So here now, I will now, we've run before, no need. So here I can say for 5 minutes. Okay, I'll go to profile plots. I'll click on J1. I'll come here, because J1 is highlighted, I'll now come here and say add it. I will now choose where I want to see what's happening. I'll click on this one, I'll say add it. I'll say find paths to tell me that P1 is going to show me result for P1 that flow into P2, flow into P5, flow into P6, flow into P8, flow into P9. So I'll say, okay, you come up with this profile. Then if I begin this thing at the beginning now, if I go back to the beginning, okay. So when there is no rain, after 5 minutes, there's no rain. So the drain, my drain is empty. My drain is empty. My drain is empty. Then I click play. It starts. Now it's a bit fast. If it's a bit fast, I can, let me check. Let me take it. Still very slow. Okay. Speed, yeah. Yeah, got it. This is speed. I will reduce the speed. So now, at 5 minutes, after 5 minutes, my drain, this is the first part, that is 0.8. Remember, this part is 3 meters. If you remember, towards the outfall, this part is 2.2. This part is 2.1. This is 1.2. This is 0.8 or 0.9. Is that okay? So that is the 5 sizes. Remember our drawing. Here, the pipe size is 0.8. Here, 1.2. Here, 2.2. Here, 2.5. Here, 3 meters. That's what we did. So that's exactly what is being displayed. So what do I do now? I'll click OK. Play. Rain has fallen. It started coming. Rain has fallen. The first has surcharged, and the first 2 manhole are not good enough. That's what this thing is telling you. The place that we did 3 meters is oversized. It's too big. Look at where the water is. But the first 2, the one that's conveying 15 hectares, I need to go and, so that my 700 or 800 will not work. I'll likely increase it to say 1 meter. So this simulation helps me to check where, see, rain has started after 30 minutes, you see. So the first to flood was this one. When it floods, it counts the first 2 manhole. So with this, I can go back and change, go back to my project view and know that this one can might increase to 1.2. Do not necessary. So it means the first two nodes are surcharging. That's what it means. Take note of that. So that is that. The next report is table reports. Table reports, there are two by objects. Okay, so table report now. Is it the link? The link reports. What do I need to see in the link? I want to see the flow. I want to see the velocity. I click OK. So this is everything I need to know about that link, that particular link. This is the entire flow. This is the velocity, and so on and so forth. Any question? So table reports. Give me everything about that particular link, velocity at that point. So you can view many different reports and then call them out. Statistics, I never tried statistics, but I know that it's people in academia. Object category. Let me say node. Each of the nodes. Okay. Okay, I'll click OK. To give me statistical reports of that particular node. So J1 is this, it does this, it does that, frequency is this, the maximum value is this, the mean value is this, and some things that it might not really make sense. These events, the histogram, the frequency plots, and so on and so forth. Statistics. Any question?
Oh, sorry, sir.
Mm-hmm.
If you go back to the layout, or more like the map,
Mm-hmm.
and you run your simulation,